In this video, I'm going to show you how to estimate a correlation. So that's when we want to compare two continuous or two scale variables. And so what you'll see here is I have SPSS open. My data is already loaded in. The data here are district level data. So it means each line or each row of our data set represents a different school district. The data contains school districts from two states, New Jersey and New York, and it's all from the year of 2016. And so let's say that we want to examine the relationship or the correlation between reading achievement and math achievement. So what I can do is I already know that around this part of my data are where the two variables are that I want to use. So we want to examine the correlation between the percentage of students in each district that are proficient in reading, that's this variable right here, and the percent proficient in each district in math. So to do that, all we need to do is go up here to our Analyze tab, click that, then scroll down to where it says Correlate, and then we're just comparing the relationship or examining the relationship between two variables. We're doing bivariate correlations. We're just going to click that option, and you can see here that I already had these variables loaded in from something earlier. So all you need to do is scroll down on the left here to see our variables. And again, you can always resize this window because by default, it's not always easy to see the full variable name. So just go ahead and make it big. And then we just find the two variables that we want to use to examine the correlation. So reading test percent proficient, and then math test percent proficient. There we go. Down here, we're going to leave these two options as a default because these are both continuous or scale variables. We're just going to use a Pearson correlation. And then we just want a two-tailed test of significance. And we're going to leave this option here. It says flag significant correlations. It just means that SPSS is going to tell us something in the output if there is a significant correlation. But something else that's useful is if we go to the option here, we'll see that there are some options for statistics that can be included and some things to do with missing values. What I'm just going to do is click this box right here to show means and standard deviations. And once we've clicked that option, we can click continue. And now we're all set to go ahead and run our correlation. So we can just click OK. And then here's the output. So we get two tables, as you can see. There's a descriptive statistics table, and then there's the correlations table. So the descriptive statistics table shows the mean, the standard deviation, and the number of observations for each variable. And then down here, we see the correlation between these two variables. And so one thing to notice is the way that this is set up is it's set up as a matrix, this correlation table. And in a way, it's redundant. So basically, this cell, the set of cells right here, is showing the correlation between percent proficient in reading and percent proficient in reading, which of course these are the same thing. So it just says correlation of 1. It doesn't even tell us anything about significance. And then this is just the number of observations for this variable like that we see up here. Down here, it's the same thing, but for percent proficient in math. So we can ignore these two cells, or so these two sets of cells, two parts of the table. And then what you'll also notice is that the information in these couple of cells is the same as the information that's up here in these couple of cells. And that's because up here it says what's the correlation between percent proficient in reading and percent proficient in math. But down here, it says what's the correlation between the percent proficient in math and the percent proficient in reading. And since this is because of the kind of relationship that we're looking at, that's the same correlation because order doesn't matter. And so it's going to give us the exact same numbers. So really, you can just pick whichever one of these two that you want to interpret. So out of these kind of 4 regions of the table, you only need to look at one. So I'm just going to look right here at math test percent proficient. And so, where it says, reading, and then over here at math. And so what this tells us, it says Pearson correlation. So this 0.841 tells us two things. So with correlations, we're looking at the direction, so positive or negative, and then the magnitude or strength of the correlation. So 0.841 means that it's a positive correlation. And because it's 0.841, that's pretty high, because remember the max is 1. It's the highest correlation you can have. So this is a pretty strong correlation. So you can say there's a strong positive correlation between the percent of students in each district that are proficient in reading and the percent that are proficient in math. And then down here, where it says significance, two-tailed, you see 0.000. So what that means is not that there's 0, but it's just a very small number here in this cell. And so significance, where it says two-tailed, so this is our p-value. So the p-value is what we use to determine whether something is statistically significant. And over here, we see that it says 0.000, so very small p-value. It's certainly lower than the convention of 0.05. And so what that means is we would interpret this to be this correlation to be statistically significant. And so those are the three things that we interpret when we're looking at a correlation. So we have direction up here in this cell, positive, so it's a positive correlation, meaning that higher reading scores are associated, or a larger percentage of students who are proficient in reading is associated with a larger percentage of students who are proficient in math. So that's positive. 0.84 so it shows that it's a very strong correlation. Generally anything above around like 0.7, 0.75 is usually considered to be pretty strong. Anything between that and say like 0.4 is generally considered like moderate-ish, and below that is weak. And then again, our p-value down here tells us that it is statistically significant. So the correlation between the percentage of students in a district that are proficient in reading and the percentage of students in that district that are proficient in math has a strong, positive, and statistically significant correlation.